Welcome back to another YouTube video. It's your tutor, Disha. Now, I trust that you're having an amazing time preparing for the upcoming chemistry examination. Today, I'll be helping you a little bit by guiding you through some of the non-metal topics that you need to revise for the examination. We say the non-metals are the elements that form negative ions by accepting electrons. Non-metals are located to the right of the periodic table, even though hydrogen spoils that trend. For the exam, it is expected for you to know the physical characteristics of non-metals versus the chemical characteristics of non-metals. Let's start with the physical characteristics of non-metals. Approaching the examination, you want to know at least 5. Yes, 5. Non-metals, they are dull in appearance. They are poor conductors of heat and electricity. There's no sea of electrons in their structure, so current or heat can't flow through them. They are non-ductile. They are brittle. They can break easily in solid form. They exhibit different states. At room temperature, some are solids, liquid, or gases. Lastly, they are non-soronous. As with metals, they are soronous because they do produce a sound. You also need to know at least 5 chemical characteristics of non-metals. Non-metals are good oxidizing agents. They normally have 4 to 8 valence electrons, depending on the group that they are found in. They are kind elements in that they gain and share electrons easily. They form oxides that are acidic. Those are some good chemical characteristics that you need to know for the exam. We can easily prepare some of these non-metal elements in the lab. Yes, we can make oxygen. We can also produce the oxide carbon dioxide and can produce ammonia. In the lab, remember, we prepared oxygen through the decomposition of hydrogen peroxide, and we also used a catalyst to speed up this process, which was manganese dioxide, and that gave us water and oxygen. How did we collect this oxygen again? Through the downward displacement of the gas, because it's less dense than air. And you also need to know how you test for these gases when they are liberated. When you place a glowing splint into the gas tube, oxygen relights the glowing splint. And don't forget about those equations. For the production of oxygen, the equation is hydrogen peroxide, which is H2O2, giving off water and the gas oxygen. Any equation that they ask you to write in the examination must be properly balanced with their respective state symbols. So let's balance this. We have 2 atoms here and 2 atoms here. We have 2 atoms of oxygen here, but on the product side, we have 3. We can balance this by placing a 2 here and a 2 here. Still not complete. We need to place our state symbols. Hydrogen peroxide is in aqueous form. Water is a liquid. Oxygen is a gas. Awesome. You can produce carbon dioxide through the reaction between an acid and a carbonate. Hydrochloric acid with calcium carbonate. I have more space down here. So remember the reactants we said was the acid plus the carbonate. So we're using the carbonate, calcium carbonate, CaCO3 plus hydrochloric acid. And here we should receive the acid salt, calcium chloride, of course the gas, and water. We have 2 atoms of chlorine on the product side and only 1 atom of chlorine on the reactant side. Similarly for hydrogen, we only have 1 on the reactant side, but 2 on the product side. We need to balance, so we can balance that by placing a 2 here. So now we have equal amounts of hydrogen and equal amounts of chlorine. Remember the state symbols, calcium carbonate. So calcium carbonate here is a solid. This is an acid, so it's aqueous. This salt is also aqueous. Carbon dioxide is a gas, and water is a liquid. What about ammonia? Ammonia can be produced via 2 ways. So you can produce it during the Haber-Bosch process, which is on an industrial scale where they combine the elements nitrogen with hydrogen. And you'll learn more about that when you are doing CAPE chemistry. And I hope some of you guys are going to do CAPE chemistry. And guess what? Admission is now open for the CAPE chemistry course here at BOA Caribbean Education. So we're expecting to see some of you guys signing up for the program to begin in September. And the simpler way to produce ammonia is by warming a base with ammonium salt. To test for ammonia, remember, it's a basic gas, can expose damp red litmus paper to the gas, and it will turn the damp red litmus paper blue. And for the equation, remember, we are reacting a base with an ammonium salt upon the action of heat. Ammonium chloride, let me see if you can see this, with a base here, calcium hydroxide, and we should get here ammonia, the salt of the base, calcium chloride, and water. Ammonium chloride here is aqueous. Calcium hydroxide here is aqueous. Ammonia here is a gas. Calcium chloride here is aqueous. And water is a liquid. The hydrogens are unbalanced. So we can balance this by placing a 2 here, and a 2 here, and a 2 here. And we should be fine. That's it with the preparation of nonmetals, specifically the gases. Let's now talk about the uses of nonmetals, including the gases, the metalloids, and the other elements. Gases, oxygen, we know that oxygen is needed for respiration. So we can find oxygen in tanks in the hospital and helping patients to respire. We can also find oxygen in scuba diving tanks. Oxygen is also used in the production of steel and in the welding process. You can find carbon dioxide in extinguishers. It is used to deprive fires of oxygen so that they won't continue to burn. In our carbonated beverage, ammonia is another interesting gas used in making fertilizers, making explosives, and also it is found in our household chemicals that we use to clean. Then for the metalloids and the other elements, there's silicon, there's phosphorus, there's carbon. We know that silicon is used to manufacture the chips in our computers. It is used to manufacture sand. Yes, the reaction of silicon and oxygen produce silicon dioxide. Silicon is also used to produce glass. For carbon, here you can find carbon being in use here in my pencils. In the pencil lead, you find graphite, which is an allotrope of carbon. Diamond is another allotrope of carbon. It is used specifically in the jewelry industry. Phosphorus is used in making fertilizers and used to make matches. Next, you need to consider the impact of nonmetals on the environment. Now, nonmetals are very useful, but on the contrary, they do contribute to the degradation of our environment. Recall, carbon dioxide is a greenhouse gas that causes global warming. The oxides of nitrogen cause acid rain. The oxide of sulfur causes smog. The nitrates and the phosphates in our fertilizers, when they run off and become introduced into our water bodies like our rivers, our streams, then those nitrates and phosphates cause the overgrowth of aquatic plants like algae through the process of eutrophication. Now that's good until the aquatic animals below the water surface begins to suffer because all the oxygen is being used up, so the aquatic animals suffer. Next thing, green chemistry. When we talk about green chemistry, we're referring to the design of chemical products as well as the mitigation strategies that exist to minimize the generation of chemical wastes. So you need to know the definition. There are about 12 principles, but I doubt you need to know all these 12 principles, but try and know at least 3 of them. And you need to know about the mechanism of green chemistry. We can use renewable energy sources are low in the liberation of toxic substances. We can recycle. We can use things that cause less pollution. And another topic under non-metals that I forgot to mention, I don't know how I'm gonna forget to mention it. You need to study water. You need to study the properties of water, the uses of water. So straight off my head, I'm thinking about some properties to remind you. Water is an excellent solvent. It has a high heat capacity. You need to know the uses of water. It's an excellent solvent. So it's good for chemical reactions in our body. It's used for transport of substances. We use it for domestic purposes. It is used as a habitat for a variety of aquatic species and so on. So that's that with non-metals. Remember, you're using these topics here to guide you in the preparation for the non-metal content of the upcoming examination. Good luck. Make me proud. Shout out to DOA's chemistry students. Hi, Alex. Hi, Shanoy. Hi, Shardy. Hi, Kason. Hi, Nikki. Okay, I'm going to stop calling y'all names.